Jai Hind everyone. So this is Dr. Avdhesh Gupta, Professor in CSE Department. So this lecture dedicated to relational database management system, or we can say that a relational database, what is relational database and how can our database management system can be converted into a relational data model. Okay. So all we know that there is a relational database and we know the DBMS, database management system. All of us studied DBMS only, but later on we know that what is database, relational database. So this lecture is basically all about the relational data model. Okay. So just the basic phenomena is that if we are saying that this particular database management system is known as relational database management system, so for to maintain its integrity or to maintain that this is the relational data model, so we have to follow some guidelines. Otherwise, a simple tabular representation of data is known as a database management system. Like say, for example, if I am asking that what is data, you are saying that it is a raw facts and figure through which we can get some information. So information is the processed data is called information. And what is a database? Database is a collection of data or collection of data in some representative manner. The representative manner is that if we are presenting the data in a tabular format, in a systematic way, then it is called database. Okay. So database is represented into a tabular format. What else? What else? Basically, we are studying that normalization is a very important topic in database management system. What we do in normalization? We have to decompose a larger table into a smaller table based on certain rules. So there are multiple tables. Like for example, I am saying a database. Database consists of a single table or multiple tables. Database consists of multiple tables. These tables are interrelated to each other. All the tables are related to each other. In a database system, there is only one table. And if we are creating only one table, we can say this is database. This is database management system. And we are creating multiple tables in a database and these tables are related to each other, then we can say that these interrelated tables can create relational database management system. So to give a proper name by EF code, basically to build a relational database model, we have to follow some EF code guidelines or EF code rules. There are 12 rules by EF code. Rule number 1 is information rule. Rule number 2 is guaranteed access rule and so on. So there are 12 rules. One is foundation rule. What is foundation rule? Foundation rule is that there is a data which is represented in tabular format. Okay. And these tabular format data, if there are multiple tables are there, so these tables are interrelated to each other. Now, we have to read some rules and identify that how many of these rules we can follow to make it RDBMS. There are 12 rules, but nobody till today, I'm not saying that the 12 rules are impossible to follow for a particular RDBMS, but in general, we are not able to follow these 12 rules in our database. We have followed only 6 rules, 10 rules, 8 rules, but if we say that we have followed all the 12 rules, this is not feasible. This is possible, but not feasible. Okay. So the very first rule is information rule. The information rule is that the data, which is the metadata, or we can say the written statement. The written statement itself, it create, like for example, I am saying that this is a Ram Kumar whose age is 36. So I am saying that Ram, 36 years old, working in AKGEC. So what do you mean? What does this line mean? This is metadata, or we can say this is the data from which we can extract some information, but maybe the information is not meaningful. Ram, we know that Ram is a person name. We know this AKG is an organization. And what is 36? 36 may be the age, maybe the 36 is the roll number, or maybe the Ram whose roll number is 36 is studying in AKGC. or the Ram whose age is 36 working in AKGEC. So that is different. If we are making a tabular format in this way. So this is the tabular representation. Their name, age and working organization. Now all of you can easily read the Ram is the name of employee whose age is 36 who work in the company AKGEC. So it means the table that is stored in tabular format and from which we can get some meaningful information is the information rule. Second rule is granted access rule. Means what? Every single data element is guaranteed to be accessible logically with a combination of table name, primary key, row value and attribute name, column name. No other means such as pointer can be used to access the data. What does it mean? It means that this is name and the name is Ram. The Ram is designated as the name of person, name of employee. So this is the access rule that if we are saying we need to identify the name of employee in an organization AKGEC. The name represents this column. So whatever in this column is this, these are the name of employee. Or we can say the Ram works in which company? Ram works in this company, works for. So this is basically granted access rule. It means, for example, we are saying that this is my roll number and I belongs to particular class. We can easily get the information that this roll number, particular roll number belongs to which class. Okay. So there is no other mean to identify that what else we can get from this table. We can get easily all the information about this table. The primary key. Primary key, it means this is uniquely identifiable key by which we can identify all other attributes of the table. Okay, so that is primary key. And primary key is a unique key, like for example, roll number. Systematic treatment of null value. This is very important because in database, null value play a very important role. Like for example, we are keeping a database as, suppose this is a database, name, age and organization. A person whose age is 36 works in AKGEC. The person B whose age is 38, it works or not? I keep it as blank. Another person C whose age is 37, it is keep it as a null. Then what is it this mean? This is null or this is null? If we are keeping it as a null, N-U-L-L, then this value treated as a null value. But keeping it as a blank, it create a blank value. Blank value, it occupies some memory also. Blank value, it cannot be treated in a database manner in a systematic way. So, whatever we are entering in a database, it is must to have any entry in a particular cell. Either the null value. Null value is an entry that this particular cell kept as a null intentionally. It is not blank. It is null. The missing value is that, but this is not the missing value. Missing value is what? We are not know that what is the exact value of this. So this is in this case where we are keeping it blank. So we should not follow this blank. We are keeping as a null value, which is interpreted as this null means we are not knowing the database right now. Whenever we get the database, whenever we get this information, we will fill it. But we are keeping as null. It may be unintentionally. It may be intentionally. It may be unintentionally. So thus this blank value doesn't represent anything. So we have to keep it a null value. Okay. Null value is a very special value that if we are saying that a primary key can hold a null value. No, I think in a primary key there is no null value, but a unique value, yes, it can be a null value. Active online catalog. It means a data dictionary. Like for example, we are saying that employee, we are saying that organization, we are keeping some sort of tabular name, some sort of column name, like for example, a short name, like for example, EMP _DESC. What does it mean? Employee description. So there is a data dictionary where we are elaborating the full value or the abbreviation of in the table where we are using abbreviations of any term. So data dictionary is keeping all the record and all information about our database. Okay. Comprehensive rule or sub-language rule. A database can only be accessed by a language having linear syntax, like for example SQL. SQL यानी कि structured query language, or we can say NoSQL also. So this language SQL is a specialized language, can be used by directly or by means of some applications, like if we are using Oracle or we are using SQL or we are using PostgreSQL, we are using some rules, some guidelines to extract the data from the given table. Okay, so this means we are using some special language in SQL language. Any other thing we are not supporting. We are not saying that this can support or this cannot support. We can access the database by these languages only. View updating rule. All the views of a database which is theoretically be updated must also be updatable by system also. If we are saying that this can be updated, we can update it, so this value can be updated by the system also. High level insert, update and delete rule. This is also very important rule, because in a database when we say that these are the anomaly, what are the different anomalies are there? Obviously the anomalies are due to insert, update and delete. These three are the basic concept of anomalies. So we have to follow that insert, update and delete type of sort of things can be handled very correctly. So the database system must support these high level syntaxes so that we can insert, update the existing record or delete the existing record. Also it supports some other functions like union, intersection, join and others. This also support basically high level. High level, it means some new sort of applications, some new sort of commands, like for aggregate function, we are using aggregate functions in our database. So this is high level. Physical data independence, and another is logical data independence. This all of you have already studied in unit 1. Like what is physical data independence, another is logical data independence. This comes under data independence. In a database or DBMS or RDBMS, the data should be independence of others. Like for example, there are 3 levels of database. You have already studied the physical level, the logical level or the conceptual level. Okay. So if we are saying that the user who is entering the database and there is an administrator who are creating or designing the database, the administrator want to change some sort of columns and column name or anything, but the user always be unaware about what is going on in behind. So it means that the user, the application is independently handled by the administrator or independently handled by the users. So logical data, what is physical data independence? The data stored in the database must be independent, that the application access the database. Any change in the physical structure of a database must have any impact of how the data is being accessed by the external application. Must not have. Means the user is accessing the database and the administrator is changing the physical schema or physical structure of the database, but the user is completely unaware. User is thinking that there is no change, what's going on. User is not knowing anything. So this is physical independence. Like this is logical data independence. The logical data in the database must be independent of its application. Any change in the logical data must not affect the application using it. Like for example, if 2 tables are merged in one, one is split into 2 different tables, there should be no impact on change on the user's application. Like you are keeping that banking applications, there is some messages came to your mobile or came to your mail that the banking server may be down for 1 hour. You can use the banking application after 1 hour from this time. You are using the banking application before this time or after this time? Have you observed any changes in your operations? I think no. As we are doing the operations previously in past, or we are doing the operation right now, are the same. But for what this 1 hour taking to change the database? In the background, the physical structure or the logical structure may be changed, but we are not aware about it. So this is logical and physical data independence. Integrity, independence. There is another. A database must be independent of the application that uses it. All its integrity constraints can be independently modified without the need of any change in the application. These rules make the database independent of the front-end application and its interface. Means what? Any type of change except logical structure and physical structure, some integrity constraint or integrity constraint can be changed in the database. So the user is unaware about what type of integrity constraint has been changed. Distribution independence. This is another independence. I am saying that we are not able to follow these 12 guidelines. We are following only a few guidelines, like 5 or 6 or 8 guidelines or 10 guidelines in general. So distribution independence, the end user must not be able to see, must not be able to understand where our database is located, where is the server, what is the table name. Have you ever seen that where is a Gmail server? I think you are not aware about it. Where is your Gmail server? Have you aware about where is a railway reservation server, airline reservation server? No. Maybe there is a one server, maybe there is a bunch of servers. We are not aware about it. Do you know the structure of database? What is the structure of database? How many columns are there? What is the width of the database? We are not aware about it. So distribution independence means the administrator itself has the power to distribute the database, to keep the database at any location, at any system, and any format. The number of column, the database design can be done by the programmer or the database administrator only. But user has to just fetching the record as per their convenience. There is no effect, there is no dependency occur between user and the administrator. Non-subversion rule. If a system has an interface that provides access to low-level record, then the interface must not be able to subvert the system and bypass security and integrity constraint also. Like for example, if I am the user and I want to access the low-level records also. So it must ask the password, it must ask the verification of yours, because the integrity constraints are like that this particular record can be accessed by this person, this particular record can be accessed by this one. So if you want to access the particular record which the authorization is not given, you need to take the authorization of that particular database. So these are the 12 code rules, EF code rules. Basically, let's take 12 rules at once. These 12 rules, all of you say that these 12 rules are very easily to find in any database, and these are very important rules. But if I am saying that please develop this application software, develop the ERP, or design a banking software, design a shopping website, anything that related to tabular format databases. So are you able to apply these 12 rules? I think maximum of students are creating a database without using normalize it. They are not using normalization. They are just creating the database, they are just creating the table and just use the table for your application purpose. The information rule is okay, but guaranteed access rule, if there is no normalization, you cannot say that we are following guaranteed access rule. Obviously, when we are creating the database, we are not keeping the constraints, like this value can be kept as a null or not. We are not considering this. If you are considering this, then you are following these rules, otherwise not. Otherwise not. Physical data independence, logical data independence. Whenever you want to change the data structure, database structure, then as per the data structure changed by the database administrator, you need to tell the programmer also that this particular application column name or that whatever want to change, it should be changed. And when the user see the its interface, it is also obviously changed. Because if you are creating that this database has 5 columns and now you have normalized it and now there are 2 tables, 3. So for the user point of view, it should not be changed. But what will happen? As an inexperienced person, we are changing the interface also. So we are not following all the rules. Yes, whenever you go to a company, when you are working, then yes, you can say that we can follow 8 rules, we can follow 10 rules, we can follow 12 rules also. Okay, so these 12 rules are guaranteed that this is the database ER diagram, RDBMS model, and it follow each and every rule and guidelines, whatever you studied in the syllabus of DBMS, like transaction processing system, concurrency control system. So these are the advanced topics. So if we are following these rules of RDBMS, then we can say we are handling a true RDBMS. Okay. So now comes next few more topics that is also related to this RDBMS, integrity constraint. What is this integrity constraint? These particular topics are some small name in our 12 rules. That's why we are discussing here. Integrity constraint. Constraints is the set of rules. Integrity constraint is a set of rule. Basically for what? To maintain the quality of the designed database. Integrity constraint ensure that the data insertion, updation, deletion or any other process have to be performed in such a way that data integrity is not affected. Thus, integrity constraint is used to guard against accidental damage of the database. If we are using integrity constraint, then accidentally whatever can be done, it should not be done. Like for example, if we are keeping that this particular column should not be kept as a blank, and the user do not know the information about this particular, like for example, I am saying what is your roll number. Maximum of you do not know the roll number of class 10th or class 12th, and there is a form in which you have to fill the roll number of class 10 or class 12. What will you do? Either you find the roll number in your mark sheet or you are keeping as a null. If you are keeping as a null, the database accept a null value or not? No, it cannot accept a null value or blank value also. So until unless you are able to find the roll number of class 10th or 12th, then only you will be able to fill the form. Otherwise, it showing that this field is compulsory, you need to enter the values. Because if we are allowing the user to keep it as a null, then maximum of you can keep this particular cell as a null value. And what will happen later? This particular null value cannot be handled because maximum of you can keep it as a blank. And we are keeping it as a compulsory field, then all of you has fetch the record from your mark sheet and then fill the database. So which is good database? The database which has exactly the true value. Okay. So these are the different types of integrity: domain integrity constraint, entity integrity, referential integrity, and key constraint. Domain constraint, it means this particular ID is an integer value and it should be 4 byte long. So this is a domain constraint. Domain constraint is what? The data type and the width of that particular column, and also the constraint that this should be null or not null. This start with 1 or any other character. So these are the domain, yani the constraint applied on the particular column can be a domain constraint. Entity integrity constraint. That primary value cannot be null. Primary value used to identify the other columns or the rows of that particular row which you want to identify of other column. A table can contain a null value other than the primary field also. Referential integrity, there is a primary key and foreign key relationship is there. Then this is a referential integrity constraint. Key constraint. Whenever we find that this is a primary key or unique key, this duplicate entry cannot be allowed. So relational model concept. What is relational model concept? A relational model can represent a table with column and rows, and each rows can be known as a tuple, and column is represented as an attribute. A domain, what is domain? Domain is the constraint. Domain is the set of atomic value that an attribute can take, a cell value. An attribute, it contains the name of column of a particular table. A relational instance. In the relational database system, the relational instance represented by a finite set of tuples. Relational instance do not have duplicate tuples also. Relational schema, it means a structure that this is a particular table name and these are the attribute name, column name. A relational key. In the relational key, each row has one or more attribute. It can be identified the row in the relational uniquely. These are some properties of relation. The name of relation is distinct and each relational set contains exactly one atomic value. Each attribute contains a distinct name. Attribute domain has no significance. Tuple has no duplicate value, and order of tuple can have a different sequences. These are some key constraints like unique, not null, default, check, primary, and foreign keys. Okay, so that's all for this RDBMS concept. So we will study few more topic in the next classes. Thank you very much.